that didn't go quite as planned.
Now the cadence, and don't break it yet, the cadence is going to be 1, 2, 3. Got it? Okay, wait! All right. We'll do it again. 1, 2, 3.
We did have a few problems, but the moment of lifting off was a great moment of relief, I think, for all of us. People have asked me if we were concerned, about our personal safety, but no, we weren't. That didn't enter into it. We were busy. We had a job to do. There was a lot to think about, and we were very excited. When we got out, we were mobbed by everybody, and it was a great moment, and it was a great airplane.
But the 747 is only meant to be a stopgap. In the mid-60s, the world wants supersonic flight, planes that can travel faster than the speed of sound. Boeing reckons it will only ever sell 50 passenger 747s. It believes the real future for the jet set is its supersonic swing wing, which will go head-to-head with the European Concorde. But the supersonic dream proves an economic dead end. It's a gas guzzler. Boeing never gets beyond this full-scale mock-up. Instead, it's the 747 with more fuel-efficient engines that goes from stopgap to ruler of the skies. Since 1968, Boeing's built over 1,400 jumbos. Together, they've flown the equivalent of 101,000 trips to the moon and back. And they've all been handcrafted here at the Boeing Mega Factory. In 43 years, that hasn't changed. Making a jumbo is still hands-on work. There is not a robot in sight.
Okay, I got a little tension. All right, we're in the hole.
In our assembly line process, it's really important to get the cadence going, or sometimes we call it the drum beat. It's all about cycling, and that is having our mechanics be able to work on a job and then cycle back to the next airplane and keep the rhythm going.
But nothing is actually made here. Everett is simply a massive assembly hub. Parts from all corners of the globe converge on Everett. Aircraft seats from Germany, wing elements from China, flaps from Australia. The new 747-8 alone needs more than 6 million parts. And critically, they all need to be here just in time. Just-in-time manufacturing is a proven method that saves Boeing money by not having to purchase and store parts too far in advance. But it's risky. Timing is everything.
Yes, we do have part shortages. The key to our success in being able to keep manufacturing building is to make sure that parts that will actually stop the production system never become short.
One of the biggest components you don't want hanging around is a $20 million engine.
The engines are an expensive commodity, and so we're managing our money from a standpoint of WIP and inventory costs. So engines are usually put on in all of our models about a day or two before they roll out of the factory, and they come to us just in time.
It's hard to misplace a 747 engine, but Boeing needs to keep track of over 6 million parts. Not all as obvious as a 7-ton engine.
Yes, sir.
How are we doing today?
Good.
I'm going to need a dipstick and probably a gun barrel drill over there.
Every part is electronically tagged, giving Boeing an instant assessment of what's gone where.
There you go. Anything
Excellent.
else?
Excellent. That'll do it.
There you go.
Thank you.
Thank you.
Making a 747-8 starts with the most important part of all, the wing. The wing assembly area takes up a quarter of the jumbo's factory space. The new wings of the 747 are the largest Boeing has ever built. Each one is big enough to fit 4 3-bedroomed houses on top. The wing design is crucial to making the new 747 more efficient and therefore greener.
The 747 for the first 40 years had a 1960s technology airfoil. And the latest modern design airfoils that have been used on the 787 have a different shape of airfoil, which improves the lift-to-drag ratio, which improves the fuel burn on the airplane.
The assembly starts with the wing on its edge to allow easy access. The wing skeleton is made of 3 spars which run along the length, joined by 55 ribs. This shape provides great structural integrity, which will be needed. The wings support the full weight of the plane in flight, the stresses of turbulence. Plus, each wing will carry up to 58 tons of fuel. The aluminium skin of the wing is attached to the frame with thousands of fasteners. Every one of them is vital. Mistakes here could cost lives. So each and every fastener is double-checked.
We're fastening up the panel to the spars and torquing it with this nut setter. And then once we're done fastening it, we go through again to make sure it's all torqued down.
As the wing nears completion, it starts to take on its unique shape. It's the shape of the wing that will lift a 440,000 kilo jumbo into the air. As wings move through the air, they create an area of low pressure above and high pressure below, which creates lift.
Whenever the airplane is in flight, of course there's air flowing around the wing, and the net pressure, if you will, on the wing is one in an upward direction.
There's just one problem. When these airflows meet at the wing tips, air from below the wing moves around to the top. This circular flow forms a vortex, or dirty air. This dirty air adds downward pressure on the wing and reduces the lift it can generate. The solution is slanted or raked wing tips. These new wing tips force the vortices to form at the very end of the wings and help reduce drag. The new design also creates new challenges. Test flights reveal a small vibration in the wings known as flutter. The wings have been oscillating up to 5 centimeters.
During the testing on the airplane, we put the airplane through all corners of the envelope, the speed envelope, the altitude envelope. When we were at high speed with certain payload on the airplane and certain fuel, we did notice a small vibration of the wing and engine combination.
In extreme cases, flutter could bring a plane down by literally shaking the wings off. To meet regulations and prevent delays, the problem with the wing needs to be eliminated, or it could ground the 747 program. And not for the first time. In the late 60s, the original 747 had a different wing issue. Wind tunnel tests showed the pressure on the wing was not distributed correctly, threatening a complete redesign. But Joe Sutter came to the rescue.
We came up with the idea of just twisting the outward wing down a couple of degrees. The thought was maybe this would work. Well, they tried that in the wind tunnel, and with just that simple fix, we solved the problems.
This simple fix works. It distributes the stresses on the jumbo's wings correctly, and the 747 is good to go. In Joe's honour, it's dubbed the Sutter Twist. The twist is key to the Incredibles completing the Jumbo on time for its launch. But the Dash 8 story takes a different twist. In a typically 21st